Right, so now we're going to look at the characteristic performance of a standard silicon diode in the forward bias direction when a sine wave is applied to it. So from the function generator main output, a signal comes in through the red wire, applied to the anode of the diode, comes out to the cathode of the diode, goes across the load resistor, 1 kilo ohm in this case, and returned to the function generator. Okay, the oscilloscope is connected in two places in this circuit. One straight across the load resistor, so with the main probe on the cathode of the diode, the screen return on the other end of the resistor, common to the black terminal for the function generator, and the other oscilloscope probe is measuring displaying us the input, and that's going to be straight on the anode of the diode, straight from the input from the function generator. So what we'll do now is we'll switch on the output in a second, just checking the parameters of the function generator. So we're on sine wave, just cycle through, check that. Yep, we've got in this case a frequency of 50 Hertz, and we're at an amplitude of 5 volts. Okay, so once we've got those set up, we can apply the output. So on the oscilloscope, we'll show first what the input's doing. It's a nice sine wave, should be 50 Hertz. Now let's look at the output compared to that input. And you'll see it's not the same. Slightly reduced amplitude, and we're only seeing parts of the positive cycle. We're not seeing any of the negative cycle because that's just not getting through that forward bias diode. Okay, so the next thing we can do is actually look at the operation if that diode is reversed. So basically, I'll just briefly disconnect the oscilloscope on the input of the diode. I'm just going to flip that diode around in the breadboard. Make sure to get a good connection. Reapply the oscilloscope probe. Nothing else in the circuit has changed. So we've still got function generator coming in, this time to the cathode of the diode. You see the band is just there. You'll hopefully see that. The grey band on the end of the diode is the cathode. Output now coming from the anode, across the load resistor, measured by the oscilloscope, returning to the function generator. As before, the only thing's changed, the diode position. So now, same inputs, same amplitude, same frequency, and we're going to just apply that on there. Now we do have a little triggering issue with the oscilloscope, which I can hopefully do by a bit of auto set. Right, here we go. And I'll just adjust those to have a common axis. And once more we see the blue input waveform is the sine wave, and the yellow output waveform is some of that sine wave. This time we see only the negative half cycles are getting through, and even they are clipped, which you can analyze using your diode theory to give some good interpretations of why that might be. Okay, thanks.